Hey, welcome to Advancing AI, brought to you by Advancing Analytics. This is where we talk all things AI and machine learning. So if you like what you see and want to see more content like this, don't forget to hit the like and subscribe button. Today, we're going to be talking about feature stores in Databricks. Why should you be using feature stores in Databricks? How does it benefit machine learning teams to use feature store in Databricks? Now, for that, we've got two very special guests. We'll be having Sappy and Ben from Databricks coming along very shortly to talk to us about just how beneficial using feature stores in Databricks is going to be for machine learning teams. You don't want to miss this session, so stay tuned. Hey, Sappy. Hey, Ben. How are you guys doing?
Hey, Gabby.
Great, Gabby.
Ben, it's great to have you on our show. I was wondering whether you could introduce yourself, please.
Sure thing, Gabby. Nice to meet you and everybody on your audience. My name is Ben McKenzie. I'm a senior solutions architect with Databricks. I'm based in Canada, just outside of Ottawa. I'm really glad to be here.
What about you, Sappy? We know you now really well, but go ahead.
Hi, everyone. My name is Sepide. I'm a senior specialist at Databricks. Ben and I work together on the MLOps stream series that you have seen some of the videos of previously.
Brilliant. So today we're going to talk about your new blog, Feature Stores. And I was just wondering whether we can go into an opening question saying, why feature stores? Why should machine learning teams out there currently use feature stores within Databricks?
It's a good question, right? So, feature stores have been around for a while, and they were developed in order to solve, I think, like 2 or 3 main problems, right? So one was ensuring that you have consistency in the data between training and inference, and there's no kind of accidental drift. Making it easier to reuse features across teams so you don't have the same teams developing similar features. And then 3, making operationalizing models simpler so you don't have this kind of complex integration layer. I think you'll see we're going to do a demo and you kind of see how operationally a feature store can really help simplify things. Those are the main points in my opinion.
I was actually, I would like to give a bit of history about what is Feature Store on Databricks. Some of you might have used the first version of Feature Store, which we released, I believe, 1.5 years ago, something like this, or maybe 2 years ago, I don't remember anymore. And what we're talking about now is the second version, which is based on Unity Catalog. Basically, we did a bit of experimentation, and based on the feedback from our customers, we found out the best way to integrate features in your data ecosystem is to bring them under the umbrella of Unity Catalog. So govern everything with Unity Catalog. And Ben is going to talk about this version. You still see the old version of the Feature Store on Databricks platform on the left-hand side under the Features tab, which might be a bit confusing, but don't worry, it probably is going to be discontinued at some point.
I mean, yeah, one of the key questions I have, right, are what are the key capabilities with integrating Feature Store now with UC? And I guess we'll see that in the demo that Ben's going to present very shortly.
Yeah.
All right, demo time.
Okay. Well, actually, I'm going to start just with talking a little bit about features and kind of showing you where they are in Unity Catalog. So I've created a catalog here called Advancing Spark. And I've got 2 different demos to kind of illustrate, but you can see that under this content streamer demo, I have a bunch of tables. And some of these are feature tables, some of them are just raw data. And really the only distinction between a regular table and a feature table is that the feature table has to have a primary key, which you can see here. This one has it. Also, it has a timestamp key related to it, something called an observation date. So I have a number of feature tables in this schema. In the demo, I'll kind of show you how we're going to use them. But I just want to maybe show you some of the features or some of the capabilities that we gain by integrating the feature store with Unity Catalog. So here, for example, is a table called Viewing Aggregates. And this example is for like a streaming content provider. So it's going to be a churn model. And in this table here, we're kind of aggregating metrics about their utilization of the service. And because it's just a Unity catalog, it's just a table in Unity Catalog, we get lineage for free, right? So we can see not only the tables that went into creating our aggregation table, but later we'll be able to see the model that's consuming it.
That's cool.
We get, insights into utilization. We get quality if we had it turned on. We have a simple permissions model here. So everything you get from Unity Catalog, you get kind of just transposes over to the Feature Store as well.
I've got a quick question, Ben. In terms of insights, then, what would you expect to see when you click on your insights option there?
So insights. So this is just a feature out of Unity Catalog, and what it mostly is showing you is utilization of a table. So who are your frequent users? Frequent dashboards. It's trying to give you a sense of which tables are important or not. So I've had this question from customers. You probably have as well. Like, do we really need all the tables we have in our lakehouse? And this is a good way to find out whether a table's not been touched in a year or more, in which case it's probably a good candidate for decommissioning.
Yeah, and also it gives you a sense of how popular features are. To see, for example, if you see a table has been used by thousands of users, then you probably would trust it more over one that has been barely used.
Yeah, that's a good feature to have, right? Yeah, that's interesting. And previously, that wasn't accessible as much, right? Seeing how popular a table is. Was that ever?
Well, that's right. And this is where the old features live. So you can click in here. You can get the original sort of Hive Metastore based features and Unity Catalog features. So it's just effectively it's another view into your feature tables within the UI right now. And you can sort by popularity or relevance. So there's a bit of intelligence that's gone into what gets presented. But to me, at least, like navigating through the catalog is probably the easier way of doing it.
Yeah, certainly.
Okay, well, if we're ready, I can jump into a small demo then.
Good stuff.
Okay. So here, as I mentioned, this is a kind of the motivation here is we're going to pretend that we're building a churn model for a streaming service. And so the first thing we're going to do is look at some of these tables. So we have a customer table here, which is a type 2 table. So it has a row effective from and a row expiration. It has information about when a customer subscribed initially, what region they are from, whether it's a premium or a standard subscription. And we'll see how we're going to extract some features from this when we build our training data set. We also have customer service calls, and this is just an aggregation of interactions with customer service. So just based on an observation date, we're doing kind of a rolling 30-day customer support contact aggregation. To be honest, it doesn't make an enormous amount of sense for like a streaming service, but I just put it in here just as another example.
Yeah.
And then we've got an aggregate table here that is computing different aggregates for how a customer has been using the service. So we've got things like total minutes viewed in the last 30-day period, number of titles completed, total titles viewed, and number of logins over a 30-day period. So that comprises our data. And now when we start thinking about how we're going to build a model, we got to think about like how are we going to orient the model and how are we going to pull in the features. And I like to think of this process as something called creating an EOL table, where EOL stands for entity, observation date, and label. So in other words, what entities am I going to make predictions about? What is the observation date, or like, for time dependent features, and most of these features are time dependent. And then what is the actual label? So I'm going to pull this out of a table called the subscription history, which is a very simple table. It has the customer ID, it has the renewal date, it has whether the contract was annual or monthly, and whether they renewed or churned. And that's going to be the basis for what I'm going to call an EOL, my renewal EOL table. Is this making sense so far? Any questions, Gabby?
No, absolutely makes sense. All you're doing now is getting you data preparation, right, for the model. So that's brilliant.
That's right. So, and this is, I feel, sometimes a neglected part of the machine learning process is really thinking about what's going into your EOL table. In this case, it's pretty straightforward. I'm going to get the customer ID, that's the entity. I'm not going to take the renewal date itself as my observation date. I'm going to roll it back 2 months, right? The purpose of making a churn model is to be able to act in a way to prevent churn. And I don't really want a model that's going to predict that they're going to churn today. I want a model that's going to predict that they're going to churn in a couple of months. That gives me time to do something. So I'm going to just roll that date back by 2 months. And then I don't necessarily want to create a model for all of my customers, right? I'm going to slice and dice the customer base and probably create multiple models based on different dimensions. So in this case, it's going to be a contract length of annual. So I'm only going to consider customers that are on an annual contract length. So I create my EOL table, and that looks like something like this. Customer ID, observation date, renew. So this is historical data that I'm going to train my model on. I also, I want to include a feature which is going to be the number of days that they've been a customer. So the number of days since their original subscription. So the intuition here is that if they've been a customer for a long time, they're probably less likely to churn than if they've been a customer for only a few months. I don't really want to compute that as a feature and store it and then have a process or a job in the background kind of updating that. So I'm just going to create a function that's going to compute the number of days since they originally subscribed, and that's going to be just computed at inference time or on the fly at inference or when I'm creating my training data set. So this is a kind of a new feature, new capability within the Databricks Feature Store.
Yeah, I was going to say, this is actually a functionality that many customers have asked me for over the years, because so many customers would tell me in the past, what is Feature Store if it's not only a lookup table?
Yeah.
Well, it's not only a lookup table, right? It is because a lot of in a lot of use cases, you might not have access to your data until the time of inference, the point of inference. A common example that we usually talk about is, for example, if you want to know the distance of someone to your store, right? You don't have this information ahead of time. So you can actually create these features in a batch mode ahead of time. And that is why we have the function serving capability that allows you to define the formula or the kind of the calculation that you need to do at the time of inference. And when the data comes in, then you throw at the function. And then
absolutely. I mean, I'm very excited about the function stuff. I think it was a limitation in search, exactly what you were saying, Seppi, not being able to compute your features real time during scoring process was a huge limitation. Now with function, that overcomes it, right?
It does, and that's a good setup for the next example I'm going to show you, which has precisely that function or that feature calculation. Okay, so once I've kind of looked at my data, I kind of understand what features are available. I define my EOL table. We'll see how that's used in a moment. And so now I'm going to define my feature lookups. So this is reasonably well documented. So it's just some syntax here. The table name, the feature names, lookup key, timestamp lookup key for any features that are time dependent. So I've got my aggregations, I've got my customer service calls, I've got my customer information where I want the initial subscription date, I've got the region, I've got my feature function, and then I need to take that EOL, I created it as a view. I'm going to pull it in as a data frame here, and then I use my Feature Store client, and I call create training data set. I pass that EOL data frame into it. I pass my feature lookups into it. I indicate what the label is, and then I exclude a bunch of columns. So these columns are important for finding the features, but I'm not going to use them in my model. So I drop the customer ID, the observation date, and even the initial subscription date I don't use. I'm going to convert that into a number of days since initial subscription. So then I generate my training data frame, and I can display it here. So this basically is going to be the data frame that I'm going to use to train my model on. And then in the next example, I'll show you, I would also use this exact same structure here to create the data for inference, but I'll show you that in another example. Any questions on this, Gabby? Does this
that makes sense? No, that's good.
Okay, great. So let's look at another example, and I'm going to take this on a little bit further, but it's going to repeat some of the same kind of considerations as we did in the previous example. So this is going to be a fraud model for credit card transactions. So here's our customer data, and what's relevant here would be, as we'll see, the zip code is going to be relevant, and member since potentially relevant, and then it's a regular type 2 table. So again, in Unity catalog, just its regular table, we just indicate what the primary key is, which would be the customer ID, and we use valid from as the timestamp key, and then the feature store with the as of time joining will kind of pick up the right version of the customer record automatically. We have another dimension table here, merchant. This one's just a type 1 table. We have a transaction table here, and this is these are the raw transaction data. So we have the primary account number, that's the customer ID, you've got the transaction ID, a date, an amount, whether it was card present or not, the entry mode, a merchant ID, security code, and finally the label, whether it was fraudulent or not fraudulent. We created some features. So a lot of credit card models will include like aggregations that represent kind of how you trying to capture the normal behavior for the cardholder. So I've got 14-day totals, 7-day totals, and transaction counts. In reality, of course, there'd be many more features, but you kind of give you the idea.
Yeah.
And then just as Seppi was sort of mentioning this as a feature, but I think a relevant feature for a credit card transaction, especially for card present transactions, is the distance between the merchant and the customer's home address. And the intuition here is that people will tend not to buy, furniture and things like that if they're, 500 miles away from home. Like if they're traveling, they're likely to buy. Their buying patterns are different. So, of course, at inference time, I don't know, I can't store as a feature where the customer is. So I need to compute this sort of on the fly. So that's what this does here. Now, it doesn't actually do it. I'm just calculating a random number just for demo purposes. But that's the intention here. Okay, so like before, I'm going to define this entity observation date label table. So I'm going to create this fraud EOL, and here I'm just pulling essentially everything from my transaction table with one restriction here. I'm only looking at card present transactions, right? So you use a different model if you're purchasing something over the internet with your card than you would if you're purchasing it from a vendor where you're actually there with your card. And just as before, I'm going to get my feature engineering client. I'm going to define my lookups. So I'm just referencing the tables, the features I want. I'm going to reference my feature function here. I'm going to load my fraud EOL table into a data frame, and I'm going to pass it into the create training data set API call, along with the feature lookups, the label, and a bunch of columns to exclude. I'm going to then generate my training data set, which looks something like this. So I've got actually the primary account number. I should have dropped that. It's not really necessary for training. So that really should have gone here as well. But you can see we've got the amount of the transaction, all of my my aggregations, and then the merchant distance from the distance to home and the label. So that's what I'm going to use to train with.
Yeah.
This is not, it's all synthetic data, so it wouldn't be a good model even if it were a decent algorithm that I selected, but it's just a very quick decision tree based model.
Yep.
I can then, with the model, I can run inference on it. This is sort of not really anything new. It's just a Python model, effectively, or Python function. And here's an example where I'm pulling the model from the ML flow run, which I'm sure your audience is familiar with. So that's all nicely integrated into the notebook. And then I can score in batch on my data.
Ben, I would like to
actually
add something here. Yeah, if you go back to the training where you were doing the training, I think it's worth highlighting here how this is different than when you would train your models without Feature Store, like data from elsewhere.
Yeah. Okay. So I think from a training perspective, the way we generated our training data set is different, right? We created it through the feature API using these lookups. And then once we train the model, we're going to use the Feature Store client to log it to MLflow. Yeah. So this is going to allow it to, it will include all of the feature lookups so that at inference time, and I'll show you that, it'll be very clear in a moment, you don't need to specify all the features, you don't need to include them, you just have to include the same features or the same lookups that were in the EOL data frame. And then it will automatically pull all those features for you.
So if you use regular MLflow.log model, does that mean it wouldn't work?
Yeah, I know it would still work. The difference here is this model, because I've specified that to use the UC registry, this model will be stored in Unity catalog, and I can actually show you where that is right here. Advancing Spark, Feature Store demo 2. No, it's Feature Store demo. So there's the model right there.
Okay.
And I've got 3 versions of it. But yeah, if you didn't use it, it would get stored in the the older model registry, but it would still do all the mechanics of pulling together your features for you would still be handled for you. So let me now, maybe I'll just kind of show you, actually I need to show you one other thing before I go to serving. If I go here to my tables, we'll notice that I've got these tables called online, online, and online. So if I want to deploy a model to a serving endpoint and I want to be able to interact with it sort of in an online manner, meaning I'm going to send it a request and I'm going to get a response back, I don't want to be trying to pull those features into the model through Delta tables, right? I want a row-oriented database that will allow me to pick out the appropriate features very quickly. So this is now very easy to do in Databricks. You can take any table and then you just indicate to create an online table with it. And that's exactly what I've done here. This customer online table is being synced. This is basically a synchronization or synced version to a row-oriented database of the customer table. And that's necessary if I want to actually deploy the model for online serving. So what that looks like, I've got a serving endpoint here, which I deployed my model to. Well, actually, I'll show you from here first. So if I want to serve this model, I can just click on this, and it brings up the create serving endpoint, which allows me to specify, which entity I want to serve. I've already done this, so I'm just going to find the serving endpoint here. Advancing Spark. And here's the model. I can then query that endpoint, and I'll just bring up an example.
So while you bring up that example, I've got a question. Are feature tables very similar to Delta tables? What's the difference there then? Yeah,
there's really no difference at all. Like a feature table is simply a Delta table that has at a minimum a primary key defined, and in many cases you want a primary key and some type of timestamp.
Yeah.
And as I say in the blog, it's our blog that we're going to release is that it's all Delta tables with a primary key can be feature tables. Not all Delta tables with a primary key should be feature tables. Obviously, it's kind of like a dashboard. You can put any Delta table can be represented in a dashboard. You don't necessarily want to do so.
No.
So I think it's a pretty fine distinction. It's really more sort of what's in the table than mechanics of how those features are kind of captured.
Yeah, and to put it in other terms, if your Delta table has a primary key, then you can use the Feature Store client to do all this training and serving and getting rid of online offline skew. So that's the advantage that it gives you. There's no really physical distinction between the Delta table and feature table objects, if that makes sense.
Brilliant.
Okay, so here's a way of really, I think, understanding what the feature store does for you. So I'm going to make an inference request to that model, which was trained on a bunch of aggregations and a bunch of like distance information, and all I'm going to provide it are the primary keys, right? So what's the primary account number? So this would be available at inference time, right? When you use your credit card. The observation date, that would be typically the current date. The merchant ID is also available at inference time. And then the amount of the transaction. And then behind the scenes, and you can see I've sent the request, I've got my result back, prediction was 0, so not fraudulent. Everything else is done for you by the feature store. So that's kind of I think the power of using a feature store is that this process here is extremely simple. If you've done this without a feature store, you probably built like some type of integration layer, right? That takes the request and then it goes out to online databases, pulls that data in, manipulates it, gets it ready, and then sends it to the model and gets the response back. So that whole process, goes away. It's basically done for you by the feature store.
Okay, so I've got a question, Ben. If you were working in a team of machine learning engineers and you've developed a fraud model, but you wanted to go back and understand how certain features were computed, how would you do that now?
Okay, yeah, that's a great question. So again, this is largely a capability that is enabled by Unity Catalog. So we would go and we would find the feature table in question. Say it was the transaction aggregates, and then from here I can look at the lineage, and I can pull up the notebooks, and I can understand exactly which notebook was used to generate the data, and I can click on it, and then I can see exactly how these features were created.
Oh, okay.
In this case, it's all pretty much synthetic data, as you would expect for a demo. But yeah, exactly. And it's one of the great, I think, one of the power of kind of integrating Feature Store with Unity Catalog is you get all of these Unity Catalog features for free, basically. And I think it's not a totally novel insight that a feature table is really just a table, right? Apart from some of the considerations around how you use it in an online fashion. And of course, you need the API to be able to stitch together all of the features for a particular model. But fundamentally, data, it's just data in a table.
Well, I think that brings us to the end of this show. I very much am looking forward to the next blog and the next video that we record together. Thank you very much for your time today, Ben and Sapi.
Thank you for having us, Gabby.
Yeah, thank you, Gabby. It was a lot of fun.
Good. All right.